Well, thank you everyone for joining today. This is, I believe, our sixth enablement session. And today I'm going to focus on the HeadSpin issue cards and just give you sort of some intuition for HeadSpin issue cards, how we think about issues and how we think about solving problems on the platform. So with regards to today, the agenda is to start by reviewing capture, the analysis and issue cards and how to create these. And then to begin discussing root cause analysis in the context of a HeadSpin session. We'll dive into the issue impact time metric and define what that means and take a few different perspectives on how that metric can be interpreted. And then we'll get into, essentially the design process or the thought process around how to go about improving the user experience using the HeadSpin issue cards. Toward the end, we'll talk about the different types of issue cards, and I'll provide some example sessions that you can access to see different types of issue cards across different data. And then we'll have a Q&A session at the end. So to start, we're going to review sessions and creating issues. So to do this, we're actually just going to jump back into the HeadSpin product. We're going to go access a device. In this case, I'm just accessing a device from the device list. This is a Google Pixel 4 XL. What I'm going to do is just demonstrate recording a session. In this case, I can choose with or without network traffic. I'm going to choose with network traffic. And as soon as this button turns green, that will indicate that we've begun profiling this session. I'll go ahead and launch just a simple website, in this case, cnn.com. Wait for this page to load. You can see here this image is taking a while to load. And then I'll stop recording. So we've done this a few times now. What we'll do is jump into this waterfall UI. Again, the waterfall UI is our primary session UI, where you can see all the different data streams that have been collected as part of a capture session, as well as, and that includes both the primary data streams, for example, the screen recording, the network traffic, in this case, both the HTTP traffic as well as the binary network traffic and the device logs. And then we also have our derived analytics, which includes summaries and other analytics on this timeline, as well as the issue cards. So today we'll focus on the issue cards. Here you can see after I've recorded the session, there's a brief time where we were analyzing some of these issues. And then we have issue cards that have been populated on the left-hand side here. You can see there's quite a few issue cards that are surfaced, and they're surfaced in ranked order according to a metric which we call impact time. And you can see that at the top right corner of every issue card. And you can see this top level union impact time metric. So today we'll talk about what this means, how to think about this, and how to think about this prioritization of issue cards based on this impact time metric. So with that, we'll jump into the issue card philosophy. So fundamentally, as you saw in the waterfall UI, we're capturing multiple data streams off of these devices, and we're aligning those on a common timeline. And that includes both the primary data as well as the derived analytics, which include the issue cards, of course. And our goal is, of course, any developer can access, for example, the device logs, and they don't need HeadSpin to do that. But HeadSpin provides value by capturing all this data, bringing it all together, and creating a story, right, out of the data for each of these tests and each of these applications. So when the customer is trying to identify issues and dig into a root cause analysis, that alignment of all the data streams that contribute to the emergent user experience is one of the core value propositions that HeadSpin brings to the table. So we're capturing data streams across the entire technology stack. So we capture the screen recording, we capture the network traffic, we capture the device logs, we capture information about which applications are being used, we capture all of this different context, which enriches your understanding of what was contributing to what the user saw on the screen. We're surfacing issues across each data stream. So when we notice that there's an issue in the user experience, we flag that. We say, oh, there's a blank screen that persisted for too long, or there's a preloader or a buffering animation that's hanging around. Maybe the video quality is degraded. And we also surface issues in terms of the network. So maybe there's a slow server, and maybe there is some error in accessing one of the server APIs, or maybe there's some issue on the device, and we provide all that context. We align these data streams, and of course, issues being one of those data streams, on that common timeline. So you can see, as I'm watching my YouTube video, for example, how is the quality of that experience evolving, and what's happening in terms of the technology stack to, at different points in time within that experience. We prioritize issues based on the impact to the end user or to the client application. So all of our issues are surfaced in or highlighted on that timeline. So that means that wherever that issue is affecting the data streams on that timeline, we surface what we call an impact, which is an event associated with that particular issue on that timeline. And we prioritize issues based on what we call the impact time, which is the amount of time that issue persisted during the session. And we prioritize issues, as you saw in that waterfall UI, and in our other UIs, like our burst UI, based on the impact to the end user or the client application. And so with the root cause analysis, what we're doing is we're typically going to start with the high priority user-facing issues, the blank screens, the poor video quality. We're going to dig down into its root causes. What particularly is happening within this similar time frame in order to create this poor user experience. And so with regards to doing a root cause analysis, actually the burst UI is designed to basically hold the user's hand and going through exactly this exercise. So in the burst UI, you have at the top level, in fact, I'll just jump into this UI. So at the top level of our burst UI, we have actually, very little information that we display. It's really just the screen recording and just launch this directly. It's the screen recording and these what we call impact bursts or blocks of time where issues are active. For some reason, this UI is not loading for me. Just give this a moment. Okay, well, while we're waiting for that, we have, what we'll see is this screen recording, and we'll see these two impact bursts, which is what we call them. And these are regions where we have issues sort of within a continuous interval, right, during the session. And the size of these blocks corresponds, or in this case, basically a bar chart, and the size of these bars corresponds to the impact time. And when you hover over it, you'll see that impact time tooltip. So here, for example, we can see that there's 1 minute, 13 seconds of impact time associated with this big block here. We have a smaller one over here that just has 317 milliseconds of impact time. So, and again, this is all on that timeline. So you can see as we scroll through this, we can see what's happening on the screen. And we can see basically that while we're in this application, there's quite a few issues that are coming up, and they're all happening in sort of a continuous manner. So when we want to prioritize improving the session, we would start with this big impact time block. We could click on this, and that will jump us into this view where we can see what we call the impact time curve, where each issue is a data point here. You can see how much impact time each issue contributes. And you can see, for example, how it contributes to the curve. So in this case, there's a small contribution up there highlighted in orange. And basically this is almost like a weighted histogram of the impact that each issue is having. So here you can see we have this high battery drain issue that persists over the entire course of this interaction, and it's contributing the most to the impact time, right, for this particular session. And when you're in this UI, basically the goal is to help you identify where the most issues are, to be able to jump into that view where you can focus on just that particular part of time where the most issues are happening. And then we have this prioritization of the issue cards based on, so this is the different types of issue cards and how much impact time each of those is contributing. You can see high battery drain is the primary. We have one big high battery drain issue. You can see each of those individual issue cards over here, again, rank ordered according to their impact time. So you can start by inspecting, for example, the most significant issue in the session and what's happening on the screen during that particular issue. But of course, you can also deep dive into other issues, for example, issues in the network traffic, slow TLS, for example. So, really this burst UI is designed to sort of guide users through this journey of focusing on what are the most significant issues, and then using this concept of impact time to prioritize and identify specific issues that are the highest value targets to address. And when we talk about impact time, there's sort of an important clarification to make, which is that impact time always includes a benchmark for performance. So when we say, for example, that there's a loading animation persisting on the screen, we don't surface issues for just, like very short loading animations. Loading animations pop up all over the place. If there's a blank screen, for example, we have that low page content issue. We don't expect content to load instantly, right? Ultimately, the applications are connected. They're fetching content over the network. It takes some time to do that. And we expect that even highly optimized applications will take some time to fetch content over the network. What we do is instead we surface issues when we know that there's something that is suboptimal. So in the case of the loading animation or low page content, we only create those issue cards when these issues persist for more than 1 second. And we use that 1 second threshold because studies by Google and others have indicated that after a second, the user has mentally disengaged from the task at hand, and you begin losing your user. So, the longer this animation or loading time takes, the more disengaged your user is, and the more likely they are to switch to another application. So impact time, you can think of as the total amount of session time affected by this issue minus the performance benchmark time. So in the case of the loading animation, the impact time would be the total session time minus this 1 second. And we can look at this, from a variety of other issue cards. So it's not just the user experience issue cards, but for example, slow TLS is looking at slow TLS handshakes that take longer than 300 milliseconds. And that 300 millisecond threshold is that performance benchmark that we're using. Slow downloads, we use this 500 millisecond threshold. Again, that's the benchmark. And for issues like connection reuse or domain charting, we have this notion of a reference impact, which is, for example, connection reuse is designed to indicate when a connection is being opened and then closed prematurely instead of being reused. And so by opening and closing a connection multiple times, you incur additional overhead for establishing the TCP and TLS handshake. And if that connection is open many times, or if the handshakes are slow enough, that can lead to a poor user experience. And so we have this impact reference. So when you click on this connection reuse, it'll highlight the original connection as well as the duplicate or reopened version of that connection. So we only attribute the impact time is only attributed to each of the reopened instances of that connection, rather than all of the connection overhead. So one way to think about impact time is as the potential for improvement. Just jump back into the slides here. So this is actually a screenshot from an older feature within the product that's been discontinued, but I think the idea here is actually pretty compelling and is a good way to think about impact time. So at the top, we have the session duration and timeline with issues and the impact time included. You can see there's a little orange bar here, an impact time of about 2 seconds. And when you play back the video from this timeline, it'll show you that screen recording with the full session and including the issue, in this case, a buffering animation. In the lower section, what we do is we basically just chop out the impact time. When you play back the video from the lower section, you can see what the user experience would look like without that issue being present. So you can see what the user experience would look like if your loading was performant, for example. So you can think of impact time really as that potential for improvement. If you keep improving the impact time for a particular issue or for a particular session, then you're improving your application, you're improving your performance, and eventually you will improve your user experience. Unfortunately, I don't have a demo, a live or interactive demo that I can share with you of this, but this was a pretty cool feature from a previous iteration of the product. So I already talked about impact time as a means of prioritization. You can see that in the burst UI, and you see that in the rank ordering in the waterfall UI issue cards. Here you can see the high battery drain has this 73 seconds of impact time, and we can see that this union impact time metric, which we'll talk about in just a second, is just over 73 seconds. So you can see that this high battery drain is really a major contributor to the impact time for the session as a whole. Okay, so at this point, I want to give you an analogy that actually Brian Colwell used to explain impact time to me when I first joined the company about 4.5 years ago. So this is what we call the table analogy. And the idea is that ultimately we'll be surfacing issue cards across all of these different data streams and identifying issues in the technology stack. And the goal, of course, is to improve the end user experience, to lead to a better experience. So the way that this is accomplished in HeadSpin is by trying to decrease the impact time by addressing these issues. And of course, the proposition here is that decreasing the impact time and fixing issues will lead to a better user experience. So let's imagine that we have a table, and let's say it has just just 3 legs here, corresponding to 3 different issue cards, issue 1, issue 2, and issue 3. We can measure the height of this table as this union impact time metric, which is this top level metric. And so if we imagine that the tabletop corresponds to the user experience and to basically issues that are pulling the user experience away from where you want it to be, maybe at the floor level, for example, then this union impact time is really measuring the height of that table. And each issue or each leg of this table has its own impact time or its own length, right? That contributes to the overall height of this table. So if you address one issue, let's say you completely resolve issue 3, the height of the table actually remains unchanged. Issue 2 is still upright and vertical, and basically contributing most of the impact time to the session. You can see, we still have issue 1, but maybe we address that, and you can see that the user experience here, it may not be substantially improved, or if we addressed issue 2 immediately, it might have been improved right away. In this case, basically issue 2 is the major driver of the user experience issue, and you can see that the union impact time is basically staying the same. So as we address issue 2, then we start seeing this union impact time decreasing, and we start seeing that issue 2 is being addressed. And of course, ideally, the goal is to get this down to the floor. So that's just an analogy, maybe a visual representation, but we don't, for any application, of course, we work with customers across essentially all connected segments, a huge number of different applications on different devices. And we can't, in terms of helping those customers improve their application and improve their user experience, it's really not possible for us to know like which specific issue is the root cause of all of their problems, right? And we don't try to, at least at the moment, we don't try to be that, one size fits all solution that tells you exactly what the problem is, and here's exactly, the improvement you're going to get. Instead, we surface those issues and make it accessible for customers to understand their technology stack and leverage their own expertise to improve their user experience. And they can do that based on their own priorities rather than priorities that we arbitrarily set for them. And ultimately, the proposition is that if they reduce the union impact time for their session, or the total amount of time in their session affected by issues, by addressing individual issues, that they can improve their user experience and, of course, improve the performance of their application. So when we go back to this issue card from the Waterfall UI, and if you click on it and it opens up, the full details here, you can see, this maybe hopefully makes a little bit more sense. At the top, we have the total impact time for all issues of this type. We have the number of issues, and we have the impact time per issue displayed as this bar chart. So you can see there's one particular issue that persists for a long period of time, and the rest of the issues are pretty short and minor. So the total impact time here is really just the number of issues, or really the sum of the impact time per issue in this chart. So it's the sum of all of these. And that's actually what you see when this visualization is closed. In fact, if I jump back into this view, you can see here, I have this visualization where each of these impacts is highlighted. And if I click on this, you can see the priorities, but you can see that they all contribute to that top level impact time for that issue card. With each issue card, of course, we have the explanation and then suggestions and additional details. And the impact time for all issue cards, if you just sum it up, can be, of course, greater than the session duration. But the union impact time which is this top level number, is bounded by the duration of the session. So you can't get any worse than having issues at all times during your session. Perfect. So now I'll just sort of briefly talk about the types of issue cards. Please note I've also included a link to the documentation in these slides down here at the bottom, where we go into more details on each of the individual issue cards, and we provide some of the summary or description of these topics that I've just discussed. So I just want to take sort of two perspectives to the types of issue cards. On the left-hand side, we have the groupings that we use to group similar types of issue cards, really from, I guess it's from like a usability perspective, I guess you could say. So we surface user experience issue cards. These are basically issues that the user will see or hear or otherwise experience as a part of their experience with the application being tested. We also surface root cause issues, which are part of that technology stack that contributes to or creates that experience. So these are issues that the user can't observe directly, but that can be the root cause or the origin of these user experience issues. We also surface warnings. In the case of warnings, these may not directly contribute to user experience or performance issues, but they may be concerns that could be worthwhile for the developer to take a look at. For example, if they're making just plain HTTP requests, they're not securing their connections, then that's potentially a security concern and something that the developer may want to know about early in the development process. And so we'll go ahead and surface those issues for the developer. And this last category is pitfalls. And so pitfalls is really more about identifying issues with how the customer is using the product. And that's sort of in two manners. One is issues with the configuration of either the application or something on the device to enable, for example, network capture. So network capture, we have a man in the middle setup. We're routing network traffic through that man in the middle and back out through the device. And we do that so that we can profile what's happening in terms of the network traffic and identify each of the events and add those to the timeline. That only works if the network traffic is debuggable. And so if it's not debuggable, then we'll surface the TLS exception issue card. And the goal there is to just highlight that there is some network traffic that we're not able to capture because it's not debuggable. And we can, of course, work with the customer to do our best to ensure that that content is made debuggable and ready to profile. Another example of a pitfall issue is our slow find element issue card for Appium or Selenium tests, where the overall duration of the session may begin to get larger and larger. The session may take longer and longer to run as the selectors used in the automation to actually select elements and interact with elements on the screen become more and more inefficient. And so in that case, we'll just let customers know that their automation could be optimized and is particularly slow for a specific command. That's just a way to help customers ensure that their automation tests are going to be having sufficient throughput and not affecting any profiling that they're trying to do. So that's one perspective. That's what you'll see in the documentation, and that's really focused on sort of the user and the developer, right, and their perspectives on these issue cards. I also want to take another perspective, which is looking at the data, right, and the different data streams and the issues that we surface there. Of course, issues are always going to be derived from some data streams, ultimately from some primary data, although there may be intermediate derivative data that contributes to creating an issue. But we can sort of think about the issue cards that we currently capture as falling into these different types of data sources. So there's user perceived loading, there's video quality issues, there's audio issues, especially like audio loudness, network issues, both in terms of HTTP as well as DNS and other network protocols. There's device performance issues in terms of, for example, battery usage or other issues on the device. There's client-side code call stack. That's sort of a mouthful, but we do have this functionality to be able to profile the client-side code for debuggable mobile applications on Android and iOS. And we can surface issues in terms of methods that are particularly slow to execute and potentially could block the UI thread and of course, create those user experience issues. We surface issues like crashes, app crashes, and from the logs. I mentioned the security issues that we surface in terms of unsecured network traffic. I also mentioned the platform usage and pitfalls around automation and debuggability, and then I guess the automation performance is sort of a related but potentially a discrete category here. So that's just two sort of different perspectives on how to group issue cards. Use whatever you find to be useful, but you may see you will see issue cards grouped according to these categories in our documentation. And of course, the issues are always going to be referring to something sort of semantically in terms of the data with these groupings on the right-hand side.